jet fuel has 10 times the explosive energy of TNT. After crashes, fire is the second biggest killer of air passengers.
I had actually accepted that was the day that I was going to die.
And if the flames don't get you, the smoke will.
If you can't breathe, you're going nowhere. You're going to die in that aircraft, full stop.
If there's a fire on board, the imperative is simple.
The only thing you can do is get on the deck as fast as you possibly can and get people out.
Every time there's a fire, airlines promise to learn the lessons. But do they? For years, the industry has struggled to combat fire on board. So why are some mistakes repeated with shocking consequences? A holidaymaker is recording in a terminal building. Suddenly, a fire breaks out on a plane outside. China Airlines Flight 120. 165 passengers are on board. The evacuation begins. What those still trapped inside don't know is that at this point, they have only 90 seconds to get out alive. It's a time limit that's been calculated from decades of disaster analysis. The fire is spreading rapidly. If the passengers are going to escape in time, it will depend on whether the lessons of the past have been learned. In particular, the lessons from a disaster that occurred 22 years earlier at Manchester Airport. This was a day that would shape the career of air crash investigator Edward Trimble.
The aircraft was departing Manchester on a flight to Corfu, quite normal in the morning, with a full plane load of passengers.
The passengers are boarding British Air Tours Flight 28M. One of the passengers is Lindsay Davies, travelling on holiday with her boyfriend.
We'd been going out together for a year, and it was our first holiday together.
In charge of the plane is Captain Peter Terrington. First Officer Brian Love is being trained on the flight and will be performing takeoff and landing.
Okay. I can take, yeah, that's fine.
The plane is a Boeing 737, a standard commercial jet for short-haul journeys. Flight 28M gets clearance for takeoff. The plane accelerates down the runway. But as it approaches takeoff speed, there's a problem.
Stop. Don't hammer the brakes. Don't hammer the brakes.
Captain Terrington takes charge, applying reverse thrust to slow down the plane.
A few people said, oh, what was that? What was that? And I think somebody did say it's a tyre burst. Not that major a thing at that point.
But outside, it's clear that it is more than just a burst tyre. Smoke billows from the plane as a fire takes hold. Smoke seeps forward from the back of the cabin.
All I was thinking was that I don't want to be near this. There is a fire at the side of me, and I am not staying in my seat. By this time, the plane is slowing down quite considerably.
Stopping. 28 Mike, we're abandoning takeoff.
Looks like there's a fire on number 1.
But unable to see the fire from the cockpit, the pilots have no idea of its severity. David Learmount is an air safety journalist.
There are no fire warning systems in the wing. They're only in the engine, and the engine itself was not on fire. So here we were with a really badly burning aeroplane, and the captain not knowing how badly the aeroplane was burning.
The acrid smoke is now filling the cabin. It's quickly becoming a death trap. But from their seats at the front, behind the forward bulkheads, the cabin crew is poorly positioned to realize the danger and notify the pilots. The only warning the pilots have is from air traffic control on the other side of the airfield.
28M, there's a lot of fire.
Do we need to evacuate passengers?
Yes, I would do, via the starboard side.
Evacuate passengers on the starboard side, please.
Only now does the evacuation begin. The passengers scramble for the exits. The 737 has 6 emergency exits, 2 at the back, 2 over the wings, and 2 at the front.
People were pushing the seats, clambering over the seats towards the front. They were panicking.
Meanwhile, before the pilots leave the cockpit, they're required to complete a 15-point checklist to establish the problem.
Parking brake. Check. Speed brake lever. Down.
But back in the cabin, the passengers are struggling to get out. The smoke is starting to overwhelm them.
It just made you feel dizzy and faint, that you were going to keel over, pass out.
Over a minute since the explosion, smoke now reaches the cockpit. Finally, the danger is obvious to the pilots. They're now required to evacuate through the cockpit window. But many of the passengers aren't so lucky. The 22nd of August 1985 becomes a black day in the history of British air travel.
This stuff came down like rain. Your eyes were all full of this filth. People were on fire and people were burning.
I saw a body draped over the overwing exit. Above that body, I saw a hand moving. I jumped out of my machine and up onto the wing of the aircraft and pulled at this arm.
And the next thing I knew, I was just lying in a lot of white foam on tarmac. And then I was in my dad's hands.
Thanks to the firemen, this boy, Christopher Lawrence, survived along with his father, but he lost his mother and sister in the fire.
If he hadn't have been there, I don't think I'd have been alive today.
It could have been me quite easily. I don't feel guilty about it because I didn't stop anybody getting off. I just did what I thought I had to do.
In total, 55 people perish in one of Britain's worst aviation disasters. Edward Trimble of the Accidents Investigation Branch takes charge.
The key thing about Manchester was the aircraft hadn't left the ground. It had merely had an aborted takeoff. The fire response was very fast, and yet 55 people had died.
So how had it all gone wrong? The first question to answer was what had caused the fire in the first place. Trimble found that an engine component known as a combustion can had exploded, blowing a hole in the left wing's fuel tank.
Which immediately allowed a large mass of fuel to be lost from that aperture, which then ignited and trailed behind the left wing of the aircraft.
Fuel had been cascading out of the hole and directly onto the scorching exhaust from the engine, creating a massive, uncontrollable fire.
Turning off to the runway to the right, you put the burning wing upwind. They inadvertently put it upwind of the actual fuselage. So the wind was blowing this fuel fire towards the fuselage.
But it turned out when investigators dug deeper into the Manchester disaster, that there was a bigger problem to address than fuel flammability. They discovered that the real killer had not been the flames at all.
They died before the flames got to them because they died of inhaling toxic smoke.
Carbon monoxide, hydrogen cyanide, the acid gases, hydrogen fluoride.
Of the 55 people who died, almost 90% were overcome by toxic gases.
Sulfur dioxide, ammonia, acrolein.
Many of them fell unconscious after just 1 or 2 breaths.
Acetaldehyde, hydrocarbons.
And nearly all were dead within just a few minutes. It's a brutal demonstration to the aviation industry of just how deadly toxic smoke can be.
It's all in there. It is a killer of a toxic mix. You're in a gas chamber, essentially.
But what was it that was generating this toxic brew?
Well, this is a piece of plasticized PVC cotton-backed fabric.
To find out, investigators reproduced the same toxic smoke that had burned at Manchester.
PVC, polyester window.
The best way to do it? An aircraft bonfire. As the fire burns, sure enough, it produces deadly levels of toxic gases.
You don't need much of such materials to be burning to produce a high concentration of these gases.
Yet at the time of the Manchester disaster, most commercial jets aligned wall to wall with these materials. Among the main killers were the very seats in which the passengers were sitting. They were made of polyurethane foam. When the seats burn, they produce hydrogen cyanide, a gas that already has an infamous reputation. It was the primary killing agent of the Nazis. Without knowing it, every passenger at Manchester was quite literally entering a potential gas chamber. But the most alarming thing of all was that the lessons from the Manchester disaster should already have been learnt. 2 years earlier, on a flight 35,000 feet above Kentucky, USA. Air Canada Flight 797 is en route from Dallas to Toronto. The flight is only half full, with 41 passengers on board. One of them is Connie Kirsch.
Well, it was, a very nice, smooth flight. I was sitting very close to the restroom, really on top of the wing. I felt very safe.
Flying the plane are Captain Donald Cameron and First Officer Claude Ouimet.
So what are you having?
Steak.
Sounds good.
They're 2 hours into the flight, and everything seems perfectly normal.
What was that?
It's the breakers.
3 circuit breakers for a rear toilet on the plane have tripped.
Flushing motor's probably overheated. Give it a few minutes.
The breakers act as fuses to protect electrical circuits on the plane. It's not unusual for them to trip if a circuit overheats. The pilots decide to let the circuits cool down before resetting the breakers. But at the back of the plane, passengers are starting to smell something strange.
Well, I can recall the first time that I felt something wasn't right. I began to smell something very peculiar. It wasn't the smell of smoke. It was the smell of something like an electrical appliance that would short out. For example, an iron or a hair dryer, something like that.
The burning smell seems to be coming from the rear toilet, right behind Connie.
The smell just got stronger, and then I noticed one of the flight attendants had come back to the bathroom.
As smoke now starts to fill the cabin, it's clear this is more than a simple overheating problem.
I knew it was serious, but I wanted to remain calm.
Hi.
In the cockpit, Captain Cameron is notified of the problem.
Can you try to put it out? Okay, thanks.
What is it?
There's smoke coming from the rear toilet.
Really, the best thing a commander can do in these situations is to get the aircraft down and land as soon as possible and evacuate the aircraft.
But there are no regulations that require the crew to land the plane immediately at the first sign of smoke. Instead, they decide to try to put the fire out first. It's a delay that will prove disastrous.
I don't think they were able to put out the fire because the fire was not visible on the plane.
What the flight attendant doesn't know is that the fire is not burning in the toilet at all. It's burning in the space between the shell of the aircraft and the interior plastic paneling. There's no way to get to it. Within a few minutes, major electrical systems on the aircraft start to fail.
We gotta go down.
It's now clear to the flight crew that this is an emergency.
Mayday, mayday, mayday.
Indianapolis ground control, over.
Air Canada Flight 797, we have a fire on board requesting emergency landing.
Roger that. Can you make Cincinnati?
Roger that.
The flight attendants came back to the rear of the plane and they asked, we would like for as many of you to move toward the front of the plane as possible. I was very scared, breathing very fast.
The plane is fitted with emergency oxygen masks, but in a fire they offer no protection.
The problem is, as the aircraft descends, there's a dilution valve in the mask, the yellow cup, which would allow you still to breathe in smoke and gases from the cabin atmosphere.
Knowing this from their training, the cabin crew instead distributes hand towels to the passengers to filter the smoke.
I really feel that the damp washcloth over my nose perhaps helped extend me the possibility of breathing a little longer.
As the plane now makes its final descent towards Cincinnati Airport, it's the toughest landing of Captain Cameron's career. It's seen through the dense smoke that's proving the biggest problem.
I don't know where we are. Are we on a mountain ledge? Are we going to run off of, are we going to hit a brick building?
But remarkably, the plane touches down safely. It's now a race against time to escape before the fire consumes the whole plane. The evacuation begins, but the cabin is now filled with toxic fumes.
I had actually accepted that was the day that I was going to die.
The fire takes hold of the entire fuselage. The emergency services battle to control it. In the cockpit, the pilots must now escape themselves.
Let's get out of here!
It's just over a minute since the evacuation began. The smoke is starting to take its toll on the remaining passengers. Many have lost the strength to move.
To a crisp. Worst thing I ever seen.
A Of the 46 people on board Flight 797, just 23 make it out alive. It remains the worst disaster in Air Canada's history. Investigators conclude that an electrical fire had started underneath the rear toilet, but the damage is so severe that the root cause cannot be found. The bigger mystery was why so many people had failed to escape from a plane that was half empty. Investigators discover that a particularly deadly form of flash fire had occurred on the flight.
Flashover is basically caused by a build-up concentration of hydrocarbon gases in the cabin. And when they reach a certain level, there will be a general flash fire.
The flash fire occurred on the plane just 90 seconds after the evacuation had begun. Some bodies are found burned in their seats. The blood samples then reveal that flash fire wasn't the only cause of death. The remaining victims had died before it even struck. The killer, toxic smoke.
If you can't breathe, you're going nowhere. If you cannot stay on your feet and reasonably conscious, you're going to die in that aircraft, full stop.
Extensive tests confirm investigators' worst fears. Passengers don't stand a chance if they're not out in just 90 seconds. At that point, the deadly combination of flash fire and toxic smoke makes the cabin non-survivable. The Air Canada disaster proves that something has to be done to protect passengers from the poisonous gases that develop. The first steps are to try and fire harden the deadly cabin materials. By treating the foam seats with the right chemicals, safety engineers could make the seats fire resistant.
Now this started life as an ordinary foam, but it won't catch fire because it has a built-in fire extinguisher. And so safe foam like this would be of use not only in aircraft, but in seating anywhere.
Fire hardening seemed like the perfect answer at the time.
It was a bit of a misnomer because it led a lot of people to believe, including a lot of investigators, that materials termed to be fire hardened would not go in fire. Wrong.
Regulators demanded that these cabin materials were able to withstand the flame of a Bunsen burner for up to 60 seconds without igniting. But a solitary flame in a testing lab didn't exactly mirror the reality of an aircraft fire.
It was withstanding the certification fire tests, but in a real fire environment, they burned very well indeed.
It turned out that fire hardened didn't mean fireproof. What's more, engineers had unwittingly created a material with an even greater killing potential.
They would burn ferociously. Not only that, they would produce more smoke and toxics than the original material had because of the additives which had been used to make them fire hardened.
At extreme temperatures, the supposed fire-resisting chemicals combusted themselves, releasing their own deadly gases. Fire hardening didn't work. While new fireproof seats have since been developed, materials had not been made safe in time for the passengers at Manchester on Flight 28M. But there was another option. Passengers would stand a much better chance of escaping in time if they were able to breathe.
As soon as you have the smoke from the fire filtering into the cabin, respiration becomes the major issue, bar none.
Edward Trimble began to explore another safety possibility after the Manchester disaster: the smoke hood. It was designed to give passengers extra breathing time. It came in many shapes and sizes because it was nothing new. At one stage, after successful trials of smoke hoods, regulators proposed that they become mandatory on all commercial aircraft. So why weren't they available to passengers?
The traditional reaction to smoke hoods by the industry is that they might delay evacuation.
Pull the hood over your head like this.
Many airlines feared that crucial seconds that could be spent evacuating would be lost by passengers as they spent time putting the masks on. But not everyone agrees.
There's been evacuation tests over the years which have shown that really generally there is no problem. A good smoke hood can be done literally in seconds. And for the expenditure of a few seconds, you can buy yourself minutes of consciousness.
Pilots already had protective breathing equipment, and smoke hoods were made available to cabin crew, but the ordinary passengers still had nothing. So when the Manchester 737 disaster quickly follows the Air Canada tragedy, the smoke hood debate becomes a burning issue. The man at the heart of it is Chief Investigator Edward Trimble.
The Manchester accident was the accident which taught me that really we had to develop a means of protecting the breathing of passengers.
In the wake of the Manchester disaster, Trimble's team begins new tests on smoke hoods.
I looked at two types. One was a filter type hood where you breathe through a filter, and the other type was the so-called breathable gas hoods, which essentially have a small oxygen cylinder.
Trimble recreates the atmosphere of a burning cabin to put these smoke hoods to the test.
And the results exceeded our expectations. We certainly had filter hoods which could give you protection for 5 minutes, and one breathable gas hood which could give you a very comfortable 20 minutes at least protection.
The industry and its regulators continued to resist smoke hoods.
We believe that the overall result is that lives will not be saved.
Trimble's recommendations were rejected and smoke hoods were shelved once again. His view is controversial, but as the capacity of commercial jets continues to grow, Trimble believes things will only get worse.
My response is, really? Are you going to wait until a very large aircraft lands again at an airport after the start of an in-flight fire, and are you going to watch it taxi in and stop and shut engines down and nobody gets off the aircraft? Are you prepared for that? Are you prepared for 500 or 600 or 700 people dead on an aircraft when you open the doors? If you are, fine. Go ahead.
So if the passengers still couldn't buy themselves more breathing time after the Manchester disaster, there was only one option for staying alive.
It's all about speed. Get out.
Experts now say that you have to get people off the plane within 90 seconds. But that's not easy in a real disaster. The tragedy at Manchester proved that smoke didn't just make breathing a problem.
You couldn't see the exit doors from the aisle. You could only see the people that were in front of you. I didn't think it was an easy plane to evacuate.
If lives were going to be saved in the future, evacuation had to be made easier. The 1985 disaster at Manchester Airport shaped the career of another man, Ed Galea. In the aftermath, he developed state-of-the-art disaster analysis software that simulated the individual behavior of every passenger on board. It's the closest experts have ever been to recreating the disaster.
The congestion here is such that this person decided the better way for them to get out is to climb over the seats.
A bottleneck then occurred at the front of the plane, where the gap between the forward bulkheads was just 57 centimeters. Another problem occurred at the overwing exit, where people were obstructed by the seats in front of the door. Ed Galea's software illustrates where the bodies were found.
And there are bodies piled on top of each other and bodies in front of the overwing exit. 2 more steps and they would have got out of the aircraft, but they, in fact, the models predicting they collapsed inside the aircraft right at the exit. And this is quite accurately representing what happened in the real situation.
It was clear from the evacuation problems at Manchester, planes simply weren't designed for people to get out in 90 seconds. More people were going to die if aircraft design didn't improve. Firstly, engineers had to address the problem of visibility in thick smoke.
The only place that you can put signs that people will have a good chance of seeing them in such a situation is near floor level.
Hot smoke fills a cabin from the top down, making the best visibility at floor level. So after Manchester, floor lighting is introduced to guide passengers to the exits. It's an improvement, but there are other design issues.
There were some fairly straightforward things that needed to be done, for instance, like improving access to the overwing exits.
Seats are removed from overwing exits as a direct result of the Manchester disaster.
The forward bulkhead setup was also recommended for widening to allow people to get through more easily.
Aircrafts generally become more open plan, and the 90-second survival limit becomes the basis for a new rule from regulators. All airlines have to demonstrate that they can evacuate a plane full of passengers within that time limit. Surviving a fire still depends on one simple thing: being on the ground. What if fire broke out on a plane above an ocean, miles from land? Swiss Air Flight 111 is 33,000 feet over the Atlantic, en route from New York to Geneva. The flight is almost full, with 229 people on board. Flying the plane are Captain Urs Zimmermann and First Officer Stefan Lowe. They're flying a McDonnell Douglas MD-11, a plane with an impressive safety record. Swiss Air's MD-11 fleet has recently been fitted with a new in-flight entertainment system in premium class that allows passengers to listen to music, watch movies, and gamble. It's a lavish addition to air travel in the 90s, but on this flight, it's about to become notorious. Almost an hour into the flight, it's a normal transatlantic crossing. But Zimmermann and Lowe notice something strange.
Do you smell that?
Yeah. What is that?
Look.
A wisp of smoke emanates from a panel in the cockpit.
It's probably just the AC.
Smoke is not unusual on aircraft air conditioning systems if they haven't been cleaned in a while. Zimmermann shuts off the system. It seems to solve the problem. The plane continues its journey over the Atlantic in the direction of Nova Scotia, Canada.
Captain.
You better go down. Swiss Air 111 Heavy is declaring pan. We have smoke in the cockpit.
The captain makes contact with air traffic control in New Brunswick to arrange landing, but the situation is not yet considered an emergency.
Swiss Air 111, good evening. Descend to 3,000 altimeters 2979.
Tim Van Beveren would become an expert on the events of this fateful evening.
At that point in time, everything was still fine. Yeah? The airplane was flying on autopilot, but nothing which indicates that the crew had serious problems at that point. The airplane was totally flyable and controllable.
Would you prefer to go into Halifax?
Affirming Swiss Air 111 Heavy. We prefer Halifax from our position.
Halifax is over 100 kilometers away. It should take them only 13 minutes to get there if they begin their descent immediately. Back in the cabin, there are no signs of the smoke. The passengers are oblivious to the problem. But by now, smoke is filling the cockpit. They need to land quickly, but the pilots are delaying their descent to work through a lengthy checklist. It's Swiss Air policy to follow the list when there's smoke in the cockpit. It has over 200 steps.
Fuel on board is 230 tons. We need to dump fuel. Maybe do that in this area during descent.
It's also a procedure to dump fuel before landing in an urgent situation. But this will take extra time that the pilots might not have. Even so, they follow procedure.
Okay, are you able to turn back to the south, or do you want to stay closer to the airport?
Okay, we are able for a left or right turn towards the south to dump.
The pilots decide to make a detour away from Halifax in order to dump the fuel safely over water. It will now take them even longer to land. Passengers are now told that the flight is being diverted.
There is a slight technical problem.
But with the plane still flying smoothly and no trace of smoke, there's no reason for them to worry. But then the lights go out.
Do not panic!
It's a small sign of what's now becoming a big problem. One by one, electrical systems on the plane are failing.
Systems just went offline.
The plane is now out of the pilot's control. These are the last few moments of the actual recording between air traffic control and Swiss Air Flight 111.
Swiss 111 Heavy, we are between 12 and 5,000 feet. We are declaring emergency now at time 0124. Roger. 11 Heavy, we starting dump now. We have to land immediate.
Swiss Air 111, you're cleared to commence your fuel dump on that track and advise me when the dump is complete. Swiss Air 111, check you're cleared to start the fuel dump.
This brief inaudible response is the last transmission from Swiss Air 111. Six minutes later, the residents of Peggy's Cove, Nova Scotia, are woken by a deafening noise. Swiss Air Flight 111 crashes into the water at over 500 kilometers per hour. All those on board are killed instantly.
We hope for the best, and we are deeply grieved that this has occurred.
It's a tragic day for the families of another 229 fallen air travelers. European and American relatives grieve on either side of the ocean that took their loved ones. Investigators now had to recover the wreckage of the plane. Over 1 million pieces are collected from the ocean. Pieced together, in an aircraft hangar. Eventually, evidence is found of an electrical fire having started in the wiring to the in-flight entertainment system.
It was a system which was not designed to be on an airplane. The system was getting too hot. It was directly wired into a main power bus with no off switch.
The fire had been caused by a luxury installation for the premium class passengers that hadn't been properly tested. The system was immediately removed from all Swiss Air planes. The cause had been found, but there was another mystery to address. Why had the pilots delayed their landing for so long? Investigators find that the 200-point checklist followed by the pilots is a major risk to air safety.
If you want to follow this checklist completely, it takes you more than 30 minutes to go through this entire procedure. You don't have that time in case that you have a fire.
The pilots had delayed the landing even further in order to follow the fuel dumping policy. The delays were hauntingly reminiscent of other disasters.
Park and brake. Check. Speed brake.
The 15-point checklist at Manchester.
You try to put it out.
The decision to fight the fire instead of landing the plane on the Air Canada flight. And now the Swiss Air pilots had made similar delays. It will remain a mystery whether the pilots could have landed in time. But it was clear that the most important lesson of all still needed to be learned.
Smoke means fire, and fire means land as soon as possible.
Get the aircraft down and land as soon as possible and evacuate the aircraft.
The only thing you can do is get on the deck as fast as you possibly can and get people out.
In the wake of the Swiss Air disaster, airlines adapted their smoke checklists to make immediate landing the first instruction, instead of the last. It may seem like common sense, but escaping quickly is still the only way to survive a fire on board. So when fire broke out on a China Airlines plane in 2006, had the industry finally learned this crucial lesson about speed? Remarkably, a full evacuation is completed in under 90 seconds. All 165 people on board escape unharmed. The passengers have glimpsed the terror of an onboard fire, but they've survived for one reason.
I think the lesson has been learned, and the lesson is incorporated in everybody's mind. Flying is probably the safest means of travel.
Today's passengers are more protected than ever. The golden lesson of getting out quickly seems to have been learned. If passengers are going to stay safe from fire, this can never be forgotten.